This is lesson 11-2, surface area of prisms and cylinders. A prism is a polyhedron with two parallel congruent faces. So notice in this picture, this is a base, which is a pentagon, and the top is a base. They are congruent faces, so this would be a pentagonal prism. A prism is named by the shape of its bases. So down on the bottom we have a triangular prism because this base is congruent to another base. And this would be, again, pentagonal prism. And then over here, this is a rectangular prism. And notice the purple could be our base, the left and right, or we could do the top and bottom because the top and bottom are congruent, or we could even do the front and the back because notice the front and the back are also going to be congruent. When we talk about surface area, one of the words we have to worry about is lateral faces. Lateral just means the opposite of a base. So in this drawing on the left, again, we'll just consider this bottom part to be our base. And then the lateral faces will be anything except for the top and the bottom. So the other four faces, front and back and left and right. In the second shape, what is our base? What shape does it form? Yep, you got it, a pentagon. So it has 5 sides. So the left and the right are the faces. The lateral faces would be the other faces. And how many other faces would there be here? 5. So a pentagonal prism has 5 lateral faces and 2 regular bases. An altitude or a height is a perpendicular segment that joins the planes of the two bases. So in these two examples, our height, if we use the blue as our base, would be this. If we use the red as our base, the height would be the distance from there to there. The next vocabulary word we're going to look at is oblique. On the left, those are right prisms. On the right, those are oblique prisms. So right means that they sit at a 90-degree angle. Oblique means that they have a curve or a slant to them. This first shape would be a rectangular prism, and here this would be considered a trapezoidal prism. And I usually don't ask you things like that. It'll be those other 3 vocab words: triangular, pentagonal, rectangular. And over here this would be a rectangular prism and a triangular prism, but just because they're oblique means that their surface areas and volumes are going to change just a little bit. So a right prism, all the lateral faces are rectangles. In an oblique prism, some or all of the lateral faces are going to be non-rectangular. So see, we have some rhombuses in here, some parallelograms. Let's practice sketching. If we do a rectangular prism, I'll give you a couple strategies here. You can just draw your front, and then what you can do is connect where you want your back to be, and all of those lines should be parallel, and then anything that's in the background should be dotted. And then we want to make the solid back, and anything that's behind should be dotted. So there's one way. Why don't you try your own? Another way I've seen is just to make your rectangle, and then you can just draw a parallel line here and a parallel line here, and then connect. For some reason it looks like a loaf of bread, but it's a rectangular prism, and I almost even made mine into cubes. Hexagonal. What shape is our base going to be? A hexagon. So I'm going to work on drawing my top hexagon first. Hexagon is 6. So I draw my top, and then I could just draw my bottom also. So I'm trying to go parallel to my top, and then I'm going to connect, 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 connect. And then I need to go ahead and dot in my graph background pieces, making sure that I'm still parallel to all the other faces. So again, lateral area is the sum of all the areas of the lateral faces. So in these two prisms, they are the same prism, all the brown is going to be the lateral face. So notice what we can do is unroll our 3D object and turn it into a net. This is called a net. So with our net, what we can do is turn this into one big rectangle. So if I unfolded it all the way, it would be a big, long rectangle. So then this would be A, this would be B, this would be C, and there's D. So what the drawing is trying to show you is that if you find the length or the perimeter of this base, and you multiply it by the height, which would be this distance right here, that's the height, you will get the area of the lateral surface. So I'm going to write down the formula as lateral area is equal to the perimeter of the base times the height. And in this case, the perimeter is really A plus B plus C plus D times the height of the object. So let's try one of these examples. Find the lateral area of the prism, round to the nearest tenth. So what shape is the base? A triangle. So what we want to do is find the lateral area, which is equal to perimeter times height. So the perimeter of that triangle, we have to use Pythagorean theorem. So we see 6 squared plus 5 squared equals x squared. So that's 36 plus 25 equals x squared. And we get 61 equals x squared. So x is going to equal the square root of 61. So this length here is the square root of 61. And I'm going to round that to the nearest tenth. So that is approximately 7.8. So we have to figure out what the height of this triangle is. And the height has to be the perpendicular distance to the base. So that's going to be the 7. So our perimeter is going to be 7.8 plus 6 plus 5 times the height, which is 7. So I see 18.8 times 7. Label would be square centimeters because this is area. The second example says find the lateral area of the regular hexagonal prism, round to the nearest tenth. So our base is a hexagon, and we want to find the area of the lateral areas. So again, the lateral area is equal to perimeter times height. So the perimeter of this hexagon is going to be 5 times 6, which is 30. And the height of our prism is 12. So 30 times 12 is 30, 360 square centimeters. So what we're going to add next is the entire surface area. It is the sum of the areas of every face. So we have to add our two bases to that lateral area. So it's going to be the area of the base times 2 plus the lateral area. So I'm going to call it 2b plus ph. And when I think about it, on those other slides when I had lateral area, that should be a capital P. And I capitalize it because it has to do with the area of the base or the perimeter of the base. So these letters need to be capitalized because they revolve around that base. So in this first example, I'm going to shade in what I think the base is. So when we find the perimeter, it's a capital P, so we want the perimeter of the base. So 4 and 4 and 3 and 6. So that's going to be 14 centimeters. Then we want the height of our prism, which is going to be 5. The area of the base is 4 times 3, which is 12. So the area of the base would be 12 square centimeters. So our surface area, again, is 2b plus perimeter times height. So this is 2 times 12. Our perimeter is 14, and our height is 5. So 94 square centimeters. Try the second one. Please hit pause while they work. So when I do this problem, my perimeter is 5, 5, 6 for 16. My height is 12. When finding the area of the base, I need to have that height. So we have to use Pythagorean theorem. So that's the triangle I cut out, and we get 4 for our height of that triangle, which makes the area of our base 12. So we have two bases at 12 each, plus the lateral surface area of 16 times 12 gives us 216 square centimeters. Try this one on your own. Please pause the video while they work. Here are my solutions. We didn't have to use Pythagorean theorem because the 3 and 4 were perpendicular distances, so those are the bases and the height. So we get two bases at 6 each, plus a lateral surface area of 72 for 84 square centimeters. Let's try this next example. I started it for us. This is a hexagonal prism, so the perimeter of the base is going to be 6 sides at 6 apiece for 36 meters. The height of the prism is then 12. For this hexagon, the formula is 1/2 ANS, apothem number of sides times the side length. So we have to draw our special right triangle. So I drew in my radius and my apothem. Central angle is 360 divided by 6 for 60. Half of 60 is 30. So I have a 30, 60, 90. Opposite of 30 is 1. Opposite of 60 is square root of 3. Opposite of 90 is double. The whole side is 6. So half of the side is 3, which makes our apothem 3 roots of 3. And that's the missing piece. So when we multiply to get the area of the base, we get 54 roots of 3. And that is review from last chapter. The lateral area is going to be all the rectangles, so that's the perimeter of the base times the height. Again, perimeter is 36, height is 12, 432 square meters. So our surface area, we're filling in everything we found, two bases at 2 times 54 roots of 3, and perimeter times height is 432. So we get 187.06. Otherwise, you could also leave this in radical form.